All right, so let's look in section 1.3 here at levels of measurement. There are four different levels of measurement that data can be classified into. That is nominal, ordinal, interval, and ratio. And we'll be kind of talking about kind of nominal and ordinal together, and then interval and ratio together. They work kind of well to compare against each other. So first of all, let's look at the nominal scale. So a nominal scale includes categories only. And some examples of categories, for example, would be eye color. All right, so what would be some examples of eye color? So if we had maybe the random variable EC to stand for eye color, we might have brown, blue, green, hazel, gray, and so on. All right. And if we were to uh, maybe collect some data on eye color, we could look at eye color of students in a class. And so we would end up making a frequency table. And so the frequency table would have maybe eye color in this column, where we would have brown, blue, green, and so on. And then here we would have the frequency. And so maybe there were 12 students with brown eyes, and there were five students with blue eyes, and one student with green eyes, and so on. So, eye color is an example of a nominal scale um, because these are labels, right? The word brown is a label. The word blue is a label. The word green is a label. And with labels, you cannot do any math with them, right? Um, you couldn't find like the average of brown and blue, by taking the word brown, adding the word blue to it, and dividing that by two. I mean, that's kind of meaningless, right? Um, but if we wanted to um, maybe find the sum of brown and blue-eyed students in the class, well, then we would add the frequencies. And that would be 12 plus 5, so there would be 17. So you could do math with the frequencies because those are numerical values. Okay, we can do math with that and come up with a sensible answer when we apply mathematical operations such as plus to it. But we can't do that with labels. Okay. Um, Now, a nominal scale, data that's in a nominal scale cannot be ordered. And what we mean by ordered is we really mean numerically ordered. All right. Um, Certainly, when you think of words, you could order it alphabetically, right? You could do like alphabetical ordering with a nominal scale, okay? But what we're referring to in this statistics class is that data can be ordered numerically. Okay. And that would be in this nominal scale. Now, we could order, eye color by frequency, maybe largest at the top, and going down to the least at the bottom. But then we would be ordering the frequency table or the frequency column and not the eye color column itself. Numbers can be assigned to characteristics for the purpose of data classification arbitrarily and without regard to order. So, um, if you were to conduct a survey and you were to ask students in a statistics classroom, um, you know, Dr. Morales is a good statistics teacher. You would have maybe, um, student number. So student number one, student number two, and so on. And then this column would be, response. Now, if a student said, I agree, you could write out the words, I agree, or you could use a number one to just represent that answer, that label, I agree. So that would be maybe a one there. And then the next student could say, I disagree. And the number zero can be applied to that label, I disagree. So we'd put a zero there. Now, even though now we've turned a categorical label into a number, that's still a numerical label. And if we were to sort this, as far as smallest to largest, for example, we would have this list would maybe have a bunch of zeros in it, and then it would have a bunch of ones in it. But the fact that we sorted this in ascending order doesn't really matter. It doesn't really mean anything. Um, so we still can't order it numerically in any way that helps or that really tells a story or makes sense. Okay. But, if you were to sort them, by the response, then you could quickly figure out, well, three didn't agree and, three did agree. You could do something like that. Um, so that's an example of a nominal scale. Now let's contrast that with an ordinal scale. So in an ordinal scale, data can be ordered, but the differences are meaningless. Comparisons are relative, but not the magnitude of the difference. So for example, let's look at, I think probably the straightforward one would be course grades, A, B, C, D, and F. So, you could take data like student ID. Okay, every student has their own student ID. And then you could have their grade in the class, and you could sort by the grade. Let's do this. Right, and so on. And so, sorting it by grade does make sense. Okay. Because we know what an A means, we know what a B means, we know what a C represents. But the differences are meaningless. So what do we mean by that? Well, what is truly the difference between an A or a B? I mean, a student that got an A could have gotten an A by getting a 90.1% in the class, and the student that got a B got an 89.9% in the class. So is there really any difference between this A and this B student? They were only 0.2% away from each other. But by the same token, this student with the A could have gotten 100%, and the student with the B could have gotten an 80%, in which case there's a difference of 20% between them. But because of this labeling system here, this ordinal scale, even though it can be ordered in a way that makes sense, you can't discern any difference that that represents because it could be a small difference like this, or it could be a huge difference like that. You just can't tell just with an A or a B. Um, Another example here would be sports team jersey numbers. So, you've got a player on a team, so you have their player name, and then you've got their jersey number, and you've got a bunch of players here on the roster, and this player has jersey number 6, this player has jersey number 10, and then maybe 15, 29, 40, 41, something like that. So they have that number on the back of their uniform when they're out there playing a game. So we could sort jersey number from smallest to largest, but does the jersey number really even make a difference? You know, uh, you know, does this 6 mean that this player is better than one with a jersey number 10? Or maybe the higher the jersey number, the better the player. But as far as I know, the number jersey that a player has nothing to do with any of their stats or abilities. It's just a unique number so that you can quickly identify a player on the field. So, the data can be ordered, but the differences are meaningless. You can't really make comparisons here. Um, another one would be best colleges in the United States. So, number one college in the United States might be the University of California, Riverside. The number 2 could be Stanford. Number 3 could be Harvard. Okay. But what does that really mean? Why did UCR come up first and Stanford came up second? Maybe, the scale or the means by which these colleges were set up was biased from the beginning based off of how they are evaluated. But we don't know, what a one being first means and being second means, just like we kind of don't really truly know what A and B means, the difference between an A and a B. It could be small, it could be large. We don't know. So that's the kind of the similarity and the difference. I mean, you can see that ordinal scale, does appear to use, it's like a hybrid label. It's like a hybrid label. And it's a hybrid because it's a label, but it could be ordered numerically. Okay, here, you might say, well, this is being ordered alphabetically, right? But it just happens to be ordered alphabetically in the same way that we would order it numerically as well, right? This is typically someone with a 90%, something in the 80s%, the 70s%, the 60s%, and so on. Um, but as far as what this represents exactly, it's hard to know. Now, if we had instead put the grade in as a 90.1 or an 89.9 instead of a letter grade, if we'd put numbers like this in, that's a different story. That's a different story. Okay, so let's stop there. We'll talk about the other two, interval and ratio scales here in the next video. All right, let me know if you have any questions.